Here are the answers for the section 4-8 homework. We're going to use factoring to solve inequalities. On page 145, we're asked to graph the solution set on a number line. In number 1, we have a binomial, and this is less than 0. This is a lot like the problems in the last section where we had polynomials that were equal to 0. And the technique that we used was to factor the left side and then to use the zero product property to solve for the variable. Let's use that same technique and factor the left side. We can factor out a greatest common factor of t, leaving t minus 4. And this is less than 0. This is where these problems are different from the previous section. Let's consider the cases where this product of two things could be less than 0. How is it possible that a product of two numbers ends up less than 0, which means negative? One of the things must be positive and the other must be negative. There are two possibilities. So case number 1, or possibility number 1, the t could be the one that's less than 0, and the t minus 4 could be greater than 0. If this is less than 0, meaning this is a negative number, and this one here is greater than 0, meaning that this is a positive number, then their product would end up less than 0. But that's not the only possibility. So let's create case number 2. The t could be greater than 0, and the t minus 4 could be less than 0. In this case, the first one is the one that's positive, and the second one is the one that's negative. But again, their product, when you times together, ends up less than 0. We're going to use the word or as our connector between the two cases. If you don't want to use the word or, you can use the union symbol. Now let's address each of these cases. Look at case 1. There's nothing we need to do with t is less than 0. That already describes the solutions for t. But for this part right here, we need to add 4 to both sides. We get t is greater than 0. Case number 1 ends up being t is less than 0 and t is greater than 0. Let's think about that a little bit. Can t be a number that's less than 0 and at the same time be greater than 0? No, it can't. That doesn't make any sense. So that first situation is an empty set. Now let's look over here at case number 2. There's nothing that we need to do on this first one, but on this one here we need to add 4 to both sides, getting t is less than 4. T is greater than 0 and t is less than 4. Let's consider those two things together. To say that t is greater than 0 and it's less than 4 is equivalent to this statement. 0 is less than t, which is less than 4. And remember that we're connecting these two cases using the word or. Let's graph this. In the first case, it's just an empty set. There's nothing to graph. But in the other case, we're going to show t is between 0 and 4. So on the number line, here is 0, here is 4. They get open circles, and we graph in between. Now for number 3. We already have factored form on the left side, and the right side already has a 0. So this is ready to use. Let's use the zero product property again. This time, consider the situation where you're multiplying two things together and the answer ends up greater than 0, which means positive. There's different ways that that could happen. Case number 1, both of the numbers could be negative. So the x minus 1 could be less than 0, and the x plus 7 could be less than 0. If both of them are less than 0, meaning both of them are negative, then their product would be greater than 0. Now the word or, and let's consider case number 2. Both of the expressions could be greater than 0. So x minus 1 is greater than 0, and x plus 7 is greater than 0. If they're both greater than 0, meaning they are both positive, then their product, positive times positive, would be greater than 0. Let's look at case 1 and solve these expressions. For this one, add 1 to both sides. We get x is less than 1. And then over here, we need to subtract 7. We get x is less than negative 7. Let's consider this. X is less than 1, and at the same time, it's less than negative 7. Putting these statements together is equivalent to just saying x is less than negative 7. Now let's go over to case number 2 and solve each of these statements. For this first one, add 1 to both sides. We get x is greater than 1. And then for this one, we need to subtract 7. We get x is greater than negative 7. Now let's consider both of these statements and figure out what it really means. X is greater than 1 and at the same time greater than negative 7. That can be written with a single statement, x is greater than 1. Let's graph x is less than negative 7 or x is greater than positive 1. Here's negative 7, here's positive 1, an open circle on negative 7, and shade to the left. For the other one, we're going to put an open circle on positive 1 and shade to the right. Number 5. We already have the 0 on the right side. On the left side, let's factor this trinomial as t plus 6 times t minus 3. I chose those two numbers because 6 times negative 3 is negative 18, and positive 6 plus negative 3 is positive 3. In this problem, we have an is less than symbol. Being less than 0 means being negative. How can you multiply two things together and end up negative? One of them must be positive and the other must be negative. There are two cases. Case number 1, the t plus 6 could be less than or equal to 0, and the t minus 3 could be greater than or equal to 0. We're saying that it's the first one that's the negative and the other one that's the positive. Or, now let's create case number 2. The first expression might be greater than or equal to 0, and the second expression might be the one that's less than or equal to 0. Go back to case 1 and let's solve these statements. Subtract 6 from both sides. We get t is less than or equal to negative 6. And then on here, add 3 to both sides. We get t is greater than or equal to 3. Let's consider these statements together. We want t to be less than or equal to negative 6 and at the same time be greater than or equal to positive 3. How can you be less than negative 6 and be greater than positive 3? You can't. This is an empty set. Now over here, case number 2, let's subtract 6 from both sides. We get t is greater than or equal to negative 6. And over here, add 3 to both sides. T is less than or equal to 3. T is greater than or equal to negative 6, and at the same time, it stays less than or equal to 3. We could write it like this. Now let's graph on the number line. The first thing was an empty set. There's nothing to graph. This one here we can graph by writing negative 6 and positive 3, putting a closed dot on both, and shading in between, because the t is in between the two endpoint numbers. Number 7, we already have the 0 on the right. Let's factor the left. This is a difference of squares. It will make v plus 5 times v minus 5. How can you multiply two things together and end up less than or equal to 0, meaning negative? One of them must be positive and the other must be the negative. So case number 1, the v plus 5 could be the one that's less than or equal to 0. And the v minus 5 would be the one that's greater than or equal to 0. Or, now case number 2. Maybe the v plus 5 is greater than or equal to 0, and it's the other one that's less than or equal to 0. Now let's solve these. This makes v is less than or equal to -5, and v is greater than or equal to +5. Can you be less than -5 and at the same time be greater than +5? This is an empty set. Okay, now over here, subtract 5 from both sides. On this one, add 5 to both sides. We want v to be greater than -5 and at the same time stay less than +5. That is possible. That is equivalent to this compound statement. And we can graph this. Here's -5 and +5, closed in dot on both, and shade in between. Number 9, we don't have a 0 on the right, so let's subtract 3 from both sides. We get k squared plus 2k minus 3 is greater than or equal to 0. Now we have the 0. And we can factor this trinomial. K plus 3 times k minus 1. I chose these numbers because 3 times -1 is -3, and +3 plus -1 is +2. We have two things times together, and the result is greater than or equal to 0. Think of that as meaning like positive. For two numbers to times together and end up greater than or equal to 0, both numbers must be negative or both numbers must be positive. So case number 1, maybe they're both less than or equal to 0. Or, now case number 2, maybe they're both greater than or equal to 0. We'll go back to case 1 and solve these for k. On this first one, we get k is less than or equal to -3, and k is less than or equal to 1. K is a number that's less than or equal to -3, and at the same time, it's less than or equal to 1. This is equivalent to the single expression, k is less than or equal to -3. Now over here on case 2, let's solve for k. K is greater than or equal to -3, and at the same time, it's got to be greater than or equal to 1. We could write the single expression, k is greater than or equal to 1. Now let's graph this part or this part. So here's -3, gets a closed dot, and you shade less than -3. Now this other piece, here's +1, it gets a closed dot, and you shade greater than the 1. I'm noticing something interesting. When we have inequalities with greater than symbols, notice our graphs have the two branches on the ends, not the shading in between. But scrolling backwards, when we had an inequality with a less than symbol, notice we get the shading in between. So observations like that can help us check if we're doing it correctly. Next, number 11, we already have the 0. Let's factor this side. Factor out a t, leaving t squared minus 9. Now factor the difference of squares. We get t plus 3 times t minus 3. Now let's consider all of the cases where you could multiply 3 things together and get a result less than 0, meaning get a negative number. When you multiply 3 factors together and you get a negative result, you have to have an odd number of negative factors. So there are some cases to consider. Case number 1, maybe the t is negative, but the other two are both positive. If one of them was negative, but these two were positive, then when you times all 3 of them together, you would get a result less than 0. Case number 2. Maybe it's the t plus 3 that's negative and the other two are positive. Case number 3. Maybe it's the t minus 3 that's negative and the other two are positive. And case number 4. Maybe all three of these numbers are negative. A negative times a negative times a negative would end up less than 0. Let's go back to each of the cases and solve for t. This one here is already good to go, and this one here we could subtract 3 from both sides, getting t is greater than negative 3. This one here we could add 3 to both sides, getting t is greater than positive 3. Let's think of all three statements together. T is a number that's less than 0, and at the same time it's got to be greater than negative 3, and at the same time it's got to be greater than positive 3. Are there any numbers that are less than 0 and at the same time they're greater than positive 3? No, there's not. So case number 1 ends up as an empty set. Now case number 2. This first piece is good to go, but this one here we could subtract 3 from both sides. And this one here we can add 3 to both sides. Now let's read all three of these and think about what it's saying. T is a number that is greater than 0, and at the same time it's less than negative 3. Are there any numbers that are greater than 0 and they're also less than negative 3? Case 2 results in an empty set. Now go over to case 3. This one's good to go. Right here we could subtract 3 from both sides. And over here we could add 3 to both sides. Let's read all three of these pieces and think about it. T is a number that's greater than 0, and it's greater than negative 3, and it's less than 3. That's possible. Case number 3 can be written as the compound inequality. 0 is less than t is less than positive 3. Now case 4. This one's good to go. Right here in the middle we can subtract 3 from both sides. And over here we could add 3 to both sides. Now let's read all pieces and think about it. T is a number that's less than 0, and it's less than negative 3, and it's less than positive 3. The only numbers that satisfy all three of those are numbers which are less than negative 3. There would also be less than 0 and less than positive 3, so we can write the single expression t is less than negative 3. In every case, we're connecting with the word or. So our answer is this, or it's this. Let's graph that. Here is 0, and here is 3. Open dot on both, and shade in between. That takes care of the case 3 situation. Now case 4, let's show less than negative 3. Here's negative 3, here's an open dot, and shade less than. So this piece takes care of the case 4. Now number 13. We don't have a 0 on one side, so let's take care of that. We're going to subtract the 6m squared from both sides. We get m cubed minus 6m squared plus 9m greater than or equal to 0. Now factor the trinomial by factoring out the GCF of m. We're left with m squared minus 6m plus 9. This is a perfect square trinomial. So we have m times m minus 3 times another m minus 3. We typically factor perfect square trinomials by writing m minus 3 once and putting an exponent of 2. But considering how I need to think of all the different cases, that's why I expanded it out. Like the last one, we have 3 numbers times together, but this time the answer ends up greater than 0. Think of that as meaning positive. How can you times 3 things together and the final result ends up positive? All of them would have to be positive. So there's only one case. The m is greater than or equal to 0, and the m minus 3 is greater than or equal to 0, and the other m minus 3 is greater than or equal to 0. I guess there's really not a need to write that same thing down twice. You're going to get the same result for m when you solve them. Let's add 3 to both sides. We get m is greater than or equal to 3. And as we said, we just find out again m is greater than or equal to 3. Let's read all of these statements together and think about what answers work for m. M is a number greater than or equal to 0, and at the same time, it's got to be greater than or equal to 3. We could write the single expression, m is greater than or equal to 3. And we can graph that. Here is 3, there's a closed dot on it, and shade greater than, meaning to the right. For the review assignment, we're going back to page 143, where we had some word problems. For question 2, the word problem is about finding 4 consecutive integers. So step 1, let's define some variables. For our first integer, call it x. Then the second one could be called x plus 1. The third one could be called x plus 2. And the fourth integer could be called x plus 3. When we read a little bit further, we see it says 3 added to the sum of the squares of the first and the second. So the square of the first would be x squared. The word sum means plus. We were doing the sum of the squares of the first and second. So the second one would be x plus 1 squared. The part that says 3 added to the sum means to just stick on a plus 3 right there. Then it says gives, or equals, the square of the fourth. That could be expressed as x plus 3 squared. This equation fits the sentences in the problem. Let's expand these binomials. We have x squared plus x to the second is x squared. Double the product, that makes 2x. Square the 1. On the right side, let's expand this one. Take the x and square it. Now double the product of those two, you get 6x. And square the 3, we get 9. Let's combine like terms and at the same time get a 0 on the right side. So x squared plus x squared is 2x squared, but then when you subtract that one away, you're left with 1x squared. We have 2x, and when you subtract the 6x away, we get negative 4x. 1 plus 3 makes a 4, but then when you subtract the 9 away, you get negative 5. And now it's equal to 0. Let's factor the left side. X minus 5 times x plus 1. I use this because negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. In the first set of parentheses, we'll get x equals 5, and in the second set of parentheses, we'll find out x equals negative 1. This was a word problem, so we need to check this against the original question. We're looking for 4 consecutive integers. So if x was 5, then our first integer is 5, second is 6, the third is 7, and the fourth is 8. Or, if x was negative 1, then the next one is 0, the next one is 1, and the next one is 2. Here are the answers to this word problem. Now number 4. The width and height of a room with a square floor total 24 feet. If the floor and ceiling areas together equal the total area of the 4 walls, find the dimensions of the room. I'm going to draw a 3-dimensional drawing of the room. We're told it has a square floor, so I'm drawing sort of a box or cube shape. Let's label what we're able to. We don't know the width or length of the room, but because it's a square floor, if we labeled one side of that floor X, then that one would also be X. And the same going around the back side and then right there. The first sentence in the paragraph says, the width and height of the room total 24 feet. So the width is X. We don't know the height, but if you add them together, it makes 24 feet. That means we can label the height as 24 take away X. Let's read further in the paragraph. If the floor and ceiling areas together, that means to add together the floor area and the ceiling area. The floor area is X times X, or X squared, plus the ceiling area would be the same as the floor, so that's another X squared. This expression shows us the floor area and the ceiling area together. We're told that that is equal to the total area of the four walls. Well, let's focus on just the right wall, the right face of this shape that I drew. The area would be its length X times its width 24 minus X. And there would be 4 of those. So we could express that as 4 times X times 24 minus X. This equation fits the clues in the paragraph. Now let's simplify this. X squared plus X squared is 2X squared. 4 times X times 24 is 96X. 4 times X times negative X is negative 4X squared. Now let's rearrange it to get a 0 on the right side. Add the 4X squared over to the left. Now we have 6X squared. And subtract the 96X over to the left. We have negative 96X. And that's equal to 0. Now we can factor this. Factor out a 6X, leaving X minus 16. And that's equal to 0. Solving this one, we get 6 times 0 equals 0. And solving this one, we get that X equals 16. Now let's check these in the original problem. The letter X was how wide and how long the floor was. Does it make sense that could be 0? That doesn't make any sense. But could a room be 16 feet wide and 16 feet long? Yeah, that makes sense. So our answer is the dimensions of the room are 16 feet by 16 feet by, now what would be the height of the room? 24 take away 16. That makes 8 feet tall. There are the dimensions of this room. For page 142, we're asked to solve these equations. So let's get a 0 on one side. We have z squared plus 2z minus 15 is equal to 0. Now we can factor t plus 5 times t minus 3 equals 0. This will make t equals negative 5, and this one will produce t equals 3. Number 16, let's factor. Binomial times a binomial using FOIL. 3a times a is the 3a squared. We need two numbers to multiply to positive 3. Because the middle's negative, they're both going to be negative. The only way to make positive 3 is with a 3 times a 1. But it matters where we put them, because we want the middle to turn out to be negative 10a. We need to put the 1 here and the 3 here, so that our outer product is negative 9a, and the inner is negative 1a. Those combine to negative 10a. Now take each factor and set it equal to 0. And solve them. This one makes a equals 1/3, and this one makes a equals 3. Number 18, let's rearrange it so there's a 0 on the right side. So we could subtract the 13r. Now factor the trinomial using FOIL. There's more than one way to make 20r squared. I'm going to try 5r times 4r. If I cannot get this to work, I'll try 10r times 2r. And if that doesn't work, we could even go 20r times 1r. Now, there are different ways to make negative 15. But one thing it does tell us is one number must be positive and one number must be negative. Let's try putting the positive here and the negative here. If it doesn't work, we'll erase it and try again. One way to make 15 is with 5 times 3. Let's try putting the 3 here and the 5 here. And check our outer product, that's negative 25r, and our inner product, that's positive 12r. What do these add to? They make negative 13r. And that's what I wanted the middle term to be. If we had put them in the wrong spots, it wouldn't have worked, and we would erase and try them in different spots. Now take each factor and set it equal to 0. Use the word OR to connect them. And solve them both. This is r equals negative 3/5, or this one is r equals 5/4. On page 139, we were doing greatest common factor and LCM. What is the most amount of r's you have here? There's only one of them. So that's the most amount you can divide into everything. Our GCF is r. Now our LCM. This time it's going to be r to the 4th power. Because of this middle term, the first multiple of r to the 4th is itself. R to the 4th times 1 makes r to the 4th. And this one can also be changed into r to the 4th if you multiply by r to the 3rd. And this last one can be changed into r to the 4th if you multiply by r squared. Number 14, we need to factor this difference of cubes. So a smaller set of parentheses and then a longer set. We have r minus 1 and then r squared plus r plus 1. This r minus r cubed is not in standard form. We're used to the highest degree term being written first. So let's rewrite it as the negative r cubed and then the positive r. Now factor out a GCF of negative r. We're left with r squared minus 1. That's a difference of squares. So we have negative r times r plus 1 times r minus 1. Now look for the greatest common factor. What's over here, and it's also over here. So our GCF is r minus 1. Now let's create the LCM. From our first expression, we need to have both of those factors in our LCM. So we need the r minus 1, and we need the r squared plus r plus 1. Now go over to this one. Is there anything we don't yet have written down? We don't have to write the negative because LCMs are never negative. Have we included an r yet? Nope, not yet. So let's put an r over here. I'm going to write it at the beginning. Have we included an r plus 1? Nope, we don't have that yet. So I'm going to put an r plus 1 on the end. So this product would make our LCM. Let's leave it in factored form.